Okay, so let's get back to the top questions from Microsoft course on LeetCode. And let's just go to one of the questions listed in the others section. Let's do single number. So the question is been given a non-empty array of integers and you have to find the element that appears only once and every other element appears twice in the array. So we need linear time complexity in this. So let's get started. I don't think I'm going to use the handwritten representation I usually do because I feel like we can just, I can explain it sufficiently just by coding it here. So what we're going to do for this is we're going to use the hash table method. If you look at the LeetCode problem for a single number, one of the solution uses an XOR method where it's they declare it and use this. The value was if the variable is called val, it was something like that. They use this operator, and it's like a four-line solution. So I'm not going to go through that one because I feel like if you were in an interview, you wouldn't suddenly go and think of that one, that way of doing it. So I'm actually going to use a hash table method which I came up with. I'm not sure. It definitely runs in linear runtime, that's for sure. So we have that, but it's not the fastest solution. But if it has linear runtime complexity, we're fine. So let's look at an example here. If we have example one, it puts 2, 2, and 1. 2 appears twice and 1 appears once, so we output 1. Same thing for example 2, 4 appears once and every other element appears twice, so we output 4. Okay, so let's create a hash table here. Key value pairs of integer. So our keys are going to be the values we get, and our values are going to be the number of times the key appears in the array, in the vector in this case. So we have 2, 2, and 1 over here, and our value for the key 2 is going to be 2, and the value for key 1 is going to be 1. So in that case, by the end of it, by the time we finish filling up the hash table, we're actually going to check for the key whose value is 1 and return that, and that's our basic procedure over here. So we're just going to call it count the number of times it appears. Actually, that's misleading because there's a count function we're going to use. This number of times value appears. Well, value is in, yeah. Okay. So let's start. We'll have a pointer going through nums. And let's use the hash function count. So what this does is it returns either 0 or 1. It returns 0 if it cannot find the hash key in the hash table, and it returns 1 if it exists. So if it's greater than 0, basically if we have it in the table, we set hash of nums of I equal to whatever it already was plus 1. Otherwise, we just set it to 1. And then we have another for loop where we just go through all the values and nums and we look for the hash value of 1. So, yep. And we return this to get rid of the non-void function error. So yeah, let me just go through this again. So this is the loop in which you go through nums and you assign the hash keys, the hash values, my bad. So for example, if we take this one, our key value pair. So it look like this. So key would be 2 and its value would be 1. Sorry, 2. And for this one, its key would be 1, value would be 1. So that's how our hash table would look. And then we go through nums again and we search for the value of 1 and we return nums with j, which would be 1. And that's the output there. So let me just see if this compiles with no errors. Okay. It's good so far. Oh, that was not expected. 1 second. Oh, I was just checking that answer and we had a very, very, very small bug. That's it. That was just a brackets issue. Should run fine now. Yep, accepted. So yeah, as you can see, it passes all the cases. It's linear runtime, and I wanted to talk about the other solution before. And this was it. It uses the XOR operator, very easy solution, but it's not what would you call intuitive, you know? So that's why I explained the hash table one in this video, but this is another solution you can use, which is much, much faster. But yeah, let me just go back to the code I used. Here we go. So as I said, we use a hash table. We go through nums and we assign our key values. And we look for the value 1 and we return the corresponding key. And that's basically how we do this.